Namaskar, welcome to the channel Anka Ananda Aharan. Today we are going to discuss about some of the aspects of elementary row operations. In the previous video we have discussed how to get the elementary matrices for the corresponding row operations. Just we will have a discussion about the notations and the meanings of elementary row operations. So there are three types of elementary row operations. First one is Ri plus Krj stored in Ri. Here, what will happen? K times of the content of jth row, the content is added to ith row. That is, and the resultant, naturally the resultant is stored in ith row. Suppose by any reason, if we while writing a coding or programming, suppose we forgot to write this part. Still, the computer will store the data in the first row, because here what happens, the amount of content of jth row is made k times and those contents are added to ith row. Finally, ith row is considered once and jth row is considered k times, and everything is stored in ith row. Here, this is called pointer. Direction of the pointer gives memory location, and the tail of the pointer represents the content to be stored. So here, this is the content to be stored and this is the memory location. So we have two options while writing it. Either we will write like this, or it is more preferable than any other notation, or else suppose we are interested to write the memory location first, then it is the other way, it can be written as KRJ. These are the two allowed notations. Rest all notations are giving incorrect representation because it is a pointer. Pointer's point gives the memory location and the tail contains the information to be stored. So we will prefer to write like this. Suppose someone is telling 5 mangoes are kept in a bucket. The answer is correct. So here 5 mangoes are taking this place and bucket is taking this place. Suppose I will change the arrow mark like this. This arrow mark I will change like this. Then what will be the meaning? A bucket is stored in 5 mangoes. Is it meaningful? The answer is no. So that's why while giving the direction of the pointer, we should be cautious which one is correct and which is not. So this is the correct representation. Next question is how to get the corresponding elementary matrices. What I will do, observe here, this is my operation, elementary row operation, and I am interested to find out the corresponding elementary matrix. What I will do, I will write the identity matrix in which 2 3 position element, which is a 0 here, which should be replaced by this 5. So I got this matrix. So here in the 2 3 position, that is this and this 2 3 position, I have replaced it by 5. Similarly, here what will happen corresponding to this? It is 1 2 position element, that is a 0, that is replaced by 3 here. Observe, we got this. So corresponding to every elementary row operation, how to get the elementary matrix? Then what's the role of elementary matrices? If this matrix is multiplied to any matrix from the left of it, this matrix, suppose this matrix I am multiplying to any matrix A from the left of it, then in this new matrix where I will be in this matrix, this operation will take place. Okay, so elementary matrices plays a significant role because simultaneously several billions of operations, billions of matrices can have this one operation done by writing a one line command E. Suppose its name is E. So E multiplied with I varies from 1 to 10 to the power 10. Still, in one line command, in all these 10 to the power 10 number of matrices, this operation will take place. So it is the significance of elementary matrices. That's why we are analyzing and storing elementary matrices. Now regarding the pointer, as I have told, in the while writing this notation, what's the meaning? This is my pointer. In front of pointer, the pointer direction gives me the memory location, and tail of the pointer, the content just before the tail of the pointer, whatever it is there, it is our data to be stored. So here 5 times of row 1 is added to row 2. That means the resultant is stored in row 2. Similarly, the same operation can be written in this way also. In row 2 we have stored 5 times of R1 plus R2. R2 plus 5 times of R1. Why I am pronouncing R2 first? Because if I will not write this, then this is the by default memory location. Whatever term, if I am writing two terms, out of which the first term will be the memory location. So that's why we should write appropriately. Next is Ri interchange with Rj. Here what happens? Identity matrix. I have second matrix. Suppose I will do R2 interchange with R3. My identity matrix is 1 0 0 0 1 0 0 0 1. Here I will interchange these two rows to get this matrix. Now when this matrix is multiplied to any matrix A, B, C, D, E, F, G, H, I, what I will get? The resultant is very easy. I need not waste much time. Simply I can replace these two rows. A, B, C, first row remains same. G, H, I, D, E, F. Okay, so the same row operation takes place if any matrix is multiplied to any elementary matrix is multiplied to a given matrix from left side, then the same row operation takes place which is applied to get that elementary matrix. So this is k times of ith row is stored in ith row. That is, ith row is replaced by k times of its contents. Now let us understand its meaning, and we will stop the video with this understanding. Suppose I have 3 baskets B1, B2, B3, and in each basket some oranges and some apples are there. Suppose first basket contains 10 oranges, 15 apples, second contains 5 oranges, 10 apples, B3 contains 10, 10 each, 10 oranges, 10 apples. Now I will do the operation. 2 times of content of basket 3 are added to basket 1. What is basket 3 content? It is 10, 10. What is its 3 times? 30, 30. So I will add 2 times, not 30, 30. It is 20, 20. That is, I will add it to it. How much it is? 30, 35. So now the first basket contains 30 number of oranges, 35 number of apples. Rest all baskets, their contents are not changing. Mind it. So this basket and this basket remains unchanged. Only change takes place in this basket. Because what I have done here, when I am writing R1 plus R2, that means the contents of row 2 are added to the contents. The contents same as the contents of row 2 are added to row 1. That means the contents of row 1 will change. But when I am writing R2 plus R1, its meaning is the contents same as the contents of row 1 are added to row 2. That means row 2 will be enriched with more contents same as R1. So in this case, the resultant will be stored here. So in both the situation, we will have different matrices or different values. So we should understand that whenever I am doing this operation, what I am doing, the first is the content of a second row contents are stored in, are added to first row. That means here only changing row is first row. Here only changing row is second row. But no question of third row takes place. So similarly in case of interchange, we will have interchange of the contents of the corresponding baskets, but third basket remains unchanged. And what is the third operation? That is contents of basket 2 is replaced by 4 times of it. That means what I have previously, I was having in basket 2 5 oranges and 10 apples. Now after operation, I will have only change in basket 2, but other 2 baskets are remaining same. With this, we will conclude today's video. Next video, few more aspects we will discuss. Thank you for your patience listening.